For students in back, can you hear me? Okay, great. So remind me if anytime you cannot hear. I got some question about the project before the class, but I didn't have time to answer because I have very limited time set up my computer before the class. So I will answer during the class. Later I will talk about the exam solution first. So the first one, I already changed this one to 35, so 10 points bonus. For this one, of course, as I said, I keep emphasizing the class. You don't need to calculate everything. You don't need to calculate everything. Because if you think about, okay, I calculate the equivalent node of F1, C1 here, F2, C2 here, that's 4 value. And for element 2, you can equivalent F1, C1, F2, C2, that's another 4 value, that's 8 value. And for calculating those 8 value, I don't know how much time you need to really do all the things. That's why I keep emphasizing that as an engineer, we need to know what do we want to solve, what are the necessary information to get that final answer. And we know that for solving this one, we don't need the equivalent force and couple here. And also for the equivalent force here, we don't need it. And equivalent force here, we don't need it. We only need 2 components for the first force vector. That is corresponding couple here and a corresponding couple here. So that's why I keep emphasizing I don't try to be like perfect calculating every single component. It's not helping you to achieve the final goal. It just wastes your life. So since we know that we only need the C at node 2 and node 3, so for the uniform distributed force, actually we only need one, and that is the uniform distributed force at the second node, equivalent couple for uniform distributed force at second node. And this one is already provided in the equation, so you can use this term directly. Makes sense or not? Just plug in this one is downward, so just negative sign. So this is equivalent force for uniform distributed force at a second node for the couple. And for this one, of course, we have homework. The homework is like this. And in the exam review that I intentionally mentioned, we may have something like this. And I also wrote the function during the exam review class. If you remember, I wrote this one in the exam review. So I'm putting the exam. So this is for coming up with the linear distributed force. This is a Q as a function of S. Of course, for any straight line, you have 2 points. At S equal to 0, it's equal to negative Q naught. At H equal to 1, it's equal to 0. So 2 equations, 2 unknowns. We solve for the 2 unknowns, 2 coefficients, and we get this expression. And again, once we have this expression, as I said, we can skip the equivalent F1 and equivalent F2 because we don't need it. So we can only calculate equivalent C1 and equivalent C2. And so because I consider there's some calculation involved, so I give 4 points for each one. 4 points for each one. So this one, simple, just use the equation directly. This one I already talked about in the exam review class. 3 points and 4 points here, 4 points here. But basically, if you know this one, of course, I know you'll get these 4 points. It's the same thing. And for the, again, no need to write 4 by 4 for each. For the first K, you only need 1 component because fixed, and this one means deflection is fixed. So we only need 1 component. For the second element, fixed. So we only need 2 by 2. Everything related to theta 3 and theta 2 and theta 3. So 2 by 2. And do assembly, of course, this is the corresponding theta 2, theta 2 components. This is corresponding theta 2, theta 2 components. So it's here, 16, 32. And we have 8 moved here, 8 moved here, 16 moved here. And for the fourth term, the two components, fourth adjoint term is couple here. This is corresponding, since this is theta 2, this is the C2. So C2 comes from two parts. One is from this element, one is from this element. And we already calculated that for the second node of first element, we have 1000. And this is also the first node of second element. And the first node and second element, we have negative 600. So it becomes 1000 negative 600. And for node 3, we have equivalent node force adjoint term is a couple here. That is calculated at 400. And we have an actual couple applied, and it's counterclockwise. So it's positive 3000. So 400 plus 3000. So that this equation is 6 points. And if you have any mistake in this 4 components, is 1 point each. And if you have any mistake in these 2 components, it's 2 points each. And now we solve the unknown degree of freedom. We need to calculate the shear force and bending moment at x point 2.5. And again, this is x-axis, and each element is 2 meters. So 2.5 somewhere. So 2.5 is a point in the second element. So we need to use the second element. And now the S is 0.25.
What if we didn't show work for that to calculate S? I just wrote S equals 0.25. I didn't write out 2.5 minus 2 over 2.
So you have this number.
I found that, but I did not.
It's fine. It's fine. Yeah, I believe that you know how to get this 0.25. It's fine if you don't have this part. I just want to make it clear here in the solution, make it as clear as possible, but it's okay if you don't have this one. Yeah. So as long as you have this 0.25, you get 1 point. And for the bending moment shear force, and of course, in the example problem we practice in class, and the homework we practice, we talk about 2 methods. So one is use K, Q equal to F, and based on sign convention, what is the relation between the external applied force and internal force, bending moment shear force, and we can find the internal. You can find shear force and bending moment at node. But here, this is 2.5. It's within the element, so we can only use the second method, which is plug in S equal to 0.25. And of course, equations are provided here. You can use this equation directly. Just plug in S equal to. So again, everything related to V, they are gone. It's only about the theta. So this is the bending moment, and this is the shear force. Any question here? So let's say, I assume, let's say if you make some calculation error in this step, and somehow you use the wrong number for all the following calculation, we only give penalty once for this calculation error, which is about 1 or 2 points off. And if you use the wrong number, but if the following process shows your understanding they are correct, we don't give you any extra penalty. No. Let's say you get 300 here, and you use 300 for all the following calculation, and you get, of course, all these values are wrong. But if your step shows this, the understanding this part, they are correct, and the understand this part, and you get S value, everything they are correct. You just use the wrong number from previous step. We don't give you extra penalty. It's only penalty once here, just 1 point off for calculation error. But of course, you need to calculation error. If it's some understanding problem, it's different problem. Yeah, if you just like really calculation error, let's say this step is correct, and you plug in the correct number, but this number is wrong. It means it's purely calculation, so it's 1 point off. Yeah. Any other question?
Understanding error, like for let's say C, like we're supposed to have 3,000 for C, and I added like 1,000. It's like
370 is given the problem. Why you use 1,000?
Well, the point is, if I make
3,000 is given here.
an example.
Okay, example. Okay.
That's an understanding. that's why I made the mistake, not a math. Would that then only stay on that? Or
You mean I give 3,000, but use 1,000? What is?
if I made a mistake like conceptually, that's why I was wrong. That's why I got the wrong number. Would that then carry on, or is it considered as a math?
Don't carry. No, we don't carry on. Yeah, we don't. We don't do that. But I just don't understand why I give 3,000, you use 1,000 for calculation. That's the part I don't understand. I mean, why? But we don't carry on. Let's say I put 3,000 here, and somehow you want to use 1,000 here, and then it means that this component is wrong. There are 2 points off, and of course you get a wrong answer here. But as long as the following step, you have this part, you have this part, you plug in the number whatever you calculate here, and you have this part correct, and you use whatever number you calculate in the previous step, we don't give you extra penalty because the 3,000 you use 1,000. You only penalty once. Yes. Any other question? Here.
So, not plugging like negative root out to pursue not.
Oh. That's true. You're correct. You're correct. Yeah, yes, you're correct. You're correct. Yes, I forgot the negative sign. I forgot the negative sign.
This example is based on a positive. This is the negative. I think the negative side of the Q-dot's already accounted for. Oh, is that? Yeah, because we show.
Yeah. I'm confusing now. Don't smith. This solution is correct. I'm confused by you guys. So it's already counted here. It's already counted here. Talk to me. Do not discuss with your friends. Talk to me. Stay quiet. Do you guys have questions? It's already counted. Okay. The solution is correct. I was scared. Any other question for this part? So I added 10 points because I do believe that compared to the rest of 3 problems, because the rest of 3 problems you don't really need much calculation. It's like only 2 or 3 steps you are done. Because for this one, it does require, especially the calculation here and calculation here. That's why I added 10 points. But in terms of this problem itself, I think it is, let's say, let me show you the thing we already practiced. We practiced interpolation. We practiced the this one. And we practiced the linear distributed load, and we talk about this one in the exam review. And we talk about something like different boundary condition and different force applied and the extras couple applied. So these are the problem we practice and calculate minimum initial force, and of course. So I do not believe this is like surprise type of question. I do not believe this is. I do agree that it takes some time for calculate the whole thing, especially for this part. That's why I 10 points. But I personally do not believe this is a surprise type of question. If you check all the examples and all the homework we practice, it's not. And especially I emphasized in the exam review class. Now for the exact approximation, I think I intentionally spent 1 class talk about the modeling accuracy, and I even put a table. This is modern accuracy. I spent about one class to talk about modern accuracy, and this is the exact solution from mechanical materials, and this is like our bin capabilities, cubic polynomial, but for different force applied to be the exact solution for deflection, they are different orders. That's why if anything that's higher than cubic polynomial, we cannot have an exact result. If it's anything lower than or equal to cubic polynomial, we have the capability. So that is for the first problem. The second step is asking about, is this exact or approximation? And of course, it's approximation. If it's something I spent one class and keep emphasizing during the exam review class, you should expect that this would happen. So this part is 5 points. If you answer approximation, that's 1 point. The explanation part is 4 points. So you need to at least for these two, you need to at least include one. You can say, of course, you can say both, but if let's say if you include this one, and this is 2 points, and if you include this one, it's 2 points. So 5 points total.
Yes.
Oh, this is I just simplify writing this way, but you can really like in your explanation you can really write it in any way as long as you explain the thing. So basically, the reason the key thing here is that because when there's a uniform distributed force applied, it should be a fourth order polynomial, and I'm not requiring you to say that this is fifth order because I'm not just going that crazy for the explanation part. So this should be fourth order, this should be fifth order. So this is what you learn from mechanical materials. But our FEA is a cubic polynomial. You don't need to really write this exactly, but anyway, you explain it that FEA, our interpolation, we use cubic polynomial. It means that it's approximation. Any question? Okay. Second problem, the calculation is much shorter. It's regular 25 points problem. So one beam problem. And I have couple applied here. There's no intention, there's no couple applied, but of course, from the picture, you know that there's no couple applied, I know too, right? If there's a couple applied, I would put something here. So basically, again, K equal to F, this is a K, this is a Q, this is equal to F. And since this pin joint, F, these are reaction force. I remember when I talked about in one classroom, I said, hey, this is couple applied, there's no couple applied. And one student told me that, oh, it's pin joint, this should be no rotation. For that part, you need to figure out what does pin joint mean? Pin joint means free to rotate, but the translational degree freedom is fixed. If at this point you are still confused if it's free to rotate for pin joint, you need to work harder. I'm not. I mean, my goal here is not criticizing anybody. I mean, no matter you learn or not learn anything, I get the same salary. It doesn't really affect me. But just imagine how painful it is that you guys go into an interview. You are sitting with a structural engineer and you need to talk to him for 1 hour. How painful is that? So it's really like I want to criticize anybody. Oh, some students still don't know what is the normal stress, what is shear stress. Some students still don't know what does pin joint mean, what does the clamp means. It's just think about your future career. You know or not know does not affect me, but affect your own future. So so this is a K matrix, this is a V and theta, and the theta here is given. Some students don't know what is radius means, a couple or rotation. When you see RAD as a senior engineer in mechanical or aerospace engineering, when you see this one, when you see rotation theta, you should know it's a rotation. For the couple, the unit should be Newton times meter. I don't think there's any confusion part for my problem statement because it's clearly say that it rotates with the magnitude of this one. So, and since there's no couple applied here, this one should be 0. So now let's check this one. This one coefficient times theta1 and this one times theta2 equal to 0. And then you can get the theta2 equal to negative half theta1. So now you have the theta2. And once we have theta1, theta2, we can do the interpolation. And of course, midpoint 0.5, s equal to 0.5. And shape function is given, theta1, theta2. Theta1 is calculated, it's given, theta2 is calculated, and you plug in, you get the deflection at midpoint. Again, I do not believe this is a surprise kind of question. Because let's say for theta given, and you need to, those kind of problem we also practiced. Theta1, theta2, theta3 given. We had similar thing in the homework. And here, it's very similar. Any question for this one?
Like if you can account the new, like if you just like I thought like if you just gave us a theta1, it seemed weird because it seemed too easy for a function, but if you just went straight to like the BMS equation and solve for
then what did you use for theta2?
No, I got confused on data rotation.
Let's say just forget about before you came to UF and you just as a kid you see this a beam problem and you apply couple here. Should this node be 0 or not 0?
No,
yeah. Just imagine I have a beam problem, deformable beam problem, and this is pin joint, this is a pin joint. I apply couple here. Should this node rotate or not? There should be some rotation, right? Yeah. Yeah, there should be some rotation. Yeah. So I don't know. I need to talk to TA. I need to talk to TA. So I don't know. My guessing is that let's say you had 0.5. You had this interpolation function. You plug in theta equal to 0. Theta2 equal to 0. Did you do this step or not?
No.
So I don't know the detail yet. This is what I gave to TA. But I'm thinking you can attach here, but you cannot get these 15 points. Yeah. But I can check with TA later for the overall performance. Because they took the exam right after the exam that went Monday night, so I didn't really check the for you guys who took the exam in the classroom, but I checked some because DRC exam they are emailed to me directly. I checked the email. I think some students did very well. I need to know the overall performance. If let's say majority of students did it wrong, I consider it's my fault. Yeah, that's the only thing I can say. But if it's that not situation, yeah, we follow gradient rubric. Yeah. I think that's a problem.
For this question, I kind of like solved this differently, and I know I solved beta 2 like kind of wrong because like my beta 2 is like 1/2 of that, but as long as I solve the beta 2 in some form, like I should get some partial credit.
Stay quiet. I cannot read here. Stay quiet. Sorry, did we say good?
You use like a different method to solve beta 2, but I know I solved beta 2 wrong. Well, I get some partial points.
What kind of different method you use for solving theta 2?
You know that like one moment, which is like moment equal to is like d1 times d1. I forgot the equation. It's like there's 4 parts. It's like d1 beta 1 b2 beta 2, and yeah, I gotta extend the moment at.
This is v1 theta 1 v2 theta 2.
Yeah, I think I did that wrong, but I didn't set it up in like a matrix form.
For solving unknown degree freedom, the only way is KQ equal to F. There's no different way to solve unknown degree freedom. FEA is all about KQ equal to F. What different method can you use?
I use like two equations, two numbers, but I didn't like set it up like the matrix form. I just like, oh, this equation and then this equation, yeah, two equations to numbers.
Just only one element. Why you have?
Yeah, I just dumping the problem. Like, I'm just asking like, why I get partial points if I acknowledge that there's a.
So let's say you have two KQ equal to F and you do assembly. Is that what you mean? We can check it later. I don't know. So yeah, you may have partial credit, but I think for this one is straightforward enough. It's one element and one KQ to F, and the K is given, right? KQ equal to F is the only way for solving unknown degree freedom in FEA. Yeah.
So I that it, but I made a dumb mistake and I put instead of theta one, I put a C one. But I solved everything like that. Would I still get credit for it?
C means a couple. Theta means
I understand I made a mistake, but I'm saying like when I
you put a C here.
credit,
You put a C here. Is that what?
C no, I put the value in C1 instead of theta.
You put value.
Like that. I realized like but then I solved and I still got theta 1, theta 2. I mean, it's wrong, obviously.
You put the theta 1 here. Then what do you put here?
I solved for it. I solved to find theta 1. See, I put the unknown value. I really do the exact thing. Why?
So you put this value here and you solve for theta 1. How? How?
Well, it's the same way you solve for any unknown value. This is an equation. Yeah, there's two unknowns. There's two unknowns.
I still cannot figure it. So first you said you put 3,000 at 1,000. I could understand. Now you put this one at theta. I still cannot understand. It's really I even put a theta here. We can talk later. I just don't know because I put a theta here, and I put a rotation here, and put a radiance here. We can talk about later. Any other question? Sorry. I told the TA to grade within 1 week. Within 1 week, yeah.
How do we know that there is a bending moment C1 at the first node, but there's no bending moment at the second node?
I talked about in class. No, sorry, in the classroom. You guys remember I talked about it in the classroom, right? I repeated several times. Do you guys remember that for this problem, because some students asked, I said, because I said, okay, it's in the picture, but in case you guys confused, there's a couple applied, there's no couple applied. And I repeated several times, there's a couple applied node 1, there's no couple applied node 2. I repeated several times. I believe so. Yeah. I repeated in both classrooms. I said, there's a couple applied node 1, there's no couple applied at node 2. Any other question? The third problem, well, this is really the same as the homework and the example problem in the class. So the example problem, I showed you how to calculate HA transpose times C times B to come up with these two matrix and then do the following steps. But here I give you these two directly, and then you do the following step. I don't see much difference. The only thing changed is that the originally is the distributed force on the edge in the x direction. Now it's distributed force on the edge in the y direction. Make sense or not? So now you see the boundary condition is fixed at bottom. You should by this time you should know what fixed means. And this two roller support, and you should know what this two roller support means. And now we know that the only free degree for them in this whole structure should be V3 and V4. All others are fixed. So we need to find the corresponding V3 component, which is only 1 for element 1 and 2 by 2 in element 2. And we do assembly, and this is a equivalent nodal force for this distributed force. And this is the same thing as the example problem we did in class. We had, it's even the same number, 100 kilonewton per meter square. And we have this one at 1 meter and thickness at 0.1 meter. So this is the same as the example problem we did in class. And we solve for the V3, V4. And for this point on the edge, I also keep emphasizing during the exam review class, if it's a point on the edge, do not go through the whole CST. Of course, you can do that. You get the same answer. It just wastes a bunch of time. So it's very obvious that this is because in the example problem, I gave 0.4, 0.4. Remember? Now it's 0.7, 0.7. What's the difference? And now for this edge 1, 2, 3. So 1, 2, 3. And we have 0.7. So the 1D inflation equation is given. U, of course, everything is 0. So it's 0. And for the V, now this is the first node, the second node is V3. This is 0. Of course, this term is gone. And this is the interpolation for 1D inflation. You can use the CST interpolation. You can use the estimation for either use this element or this element. It's fine. You get the same answer. It just takes more time. Any question? Talk to me. Talk to me. Do not discuss with friends.
Like instead of going across, I think I see this way. How many points do I do for if I like everything? So for the last part, you plug in the two V's. If I use the wrong V, yeah, like one of those I think I got wrong. I don't remember, so I feel like I did one wrong.
Oh, what do you mean by round V? Did you calculate the V here correct?
I think so, yeah.
Then 2V here, the same number. How wrong it can be? I mean, let's say you made a mistake, V3, V4, but V3 for the same number. How wrong it can be? Yeah, okay. So this one is a very standard problem. It's simplified example problem in class, and we practice similar problem in the homework. And the calculation is really not like needs heavy calculation. Any question for this one? And for the last one, yes, because if let's forget about FEA. Think about mechanics materials. The first class in mechanics materials, you have something fixed at the bottom, and you have a tension applied to the structure. What is the stress in the structure? F of A. F of A is uniform distribution force in the whole structure is tensile stress caused by tension force. F of A. It originally to be constant, and we use the constant strain, constant stress triangle to model it. Of course, we can get exact result. And this is a part you can check my recording of the exam review. I talk about this exact same thing in the exam review class. I even I did demonstration. You fix at the bottom and apply tension compression. Right? You can check my recording. I have proved it. I talk about this part in the exam review class. Any other question? So again, if you just answer exact, but your explanation is completely unrelated, it's just this one. This part is 1 point, and the explanation part is 4 points. Any question? Okay. The last one again is the type of question we practiced repeatedly in the example and homework. There's really nothing different because I can show you here that the example, actually the thing we practice in the homework is more difficult, but this is the one we practice in the example. This is the one in the homework, and this is our, where did this? Yeah, this is our exam problem. It's the same, right? So coordinates are given. The only non-zero displacement and node 2, 0.1. U2 equal to 0.1. All others are 0. So based on the, again, as I said, do not calculate everything. Because if you know that the only non-zero degree freedom is U2, you don't need to calculate F1, B1, C1, F2, C2, B2. F3, B3, C3. You only need everything related to node 2. So only need to calculate F2, B2, C2. So do interpolation, you know that this part will be gone. You only need this one single term. So this is the only thing you need to calculate. And interpolation part. And for the strain part, as I said, there are two different methods. You can use the B matrix times degree freedom Q, and the Q for the whole vector, U1, V1, U2, V2, U3, V3, all the others are 0. Only non-zero is U2 equal to 0.1. You can use that method, but I think it's easier because we already have the expression here, and I added the strain definition here. So I think but it's easier, but you can also use B times Q. And from strain to stress, C matrix. And this part I already done in the example problem. And we also practice in the homework problem. Any question here? This is really a standard problem, same as what we will practice exactly.
Thinking about it in my head, like I was confused why there was a like vertical stress at that midline, because technically like it was all like going towards that horizontal force, like I don't know, conceptually.
Question. Yes, I guess what I want to ask. So the question, I just repeat it because so the question is, when there's only this force applied, why there's a strain in the y direction, right? So let's say first, if I change this one, something like this, and it's rectangular shape, and apply force, tensile force, there should be, and also I need to change the boundary condition to one pin joint and one roller support. And in that situation, it only has strain and stress, normal strain and stress in the x direction. The y direction should be 0. But now why there's y generated? Strain in the y direction or stress in the y direction generated. Stress in the y direction, sorry. Stress in the y direction. Because now you can imagine when you have a 2D plane stress situation, you apply force here. And if this is the pin joint and if this is a roller support, it should be free to contract. Because simply if it's 2D problem, you apply tensile force, there should be contraction on the lateral direction. Then it's free to contract if the stress should be 0. Make sense or not? Now it's not free to contract. Now since it fixed the whole edge, so basically they want to contract to have 0 stress, but now I fix it contract. So basically there's a stress generated because when it want to have contraction on the lateral direction, but I still maintain the same dimension here. That's why it generates stress in the y direction. That is a great question. What? Let's say I can do it clearly here. If we had a situation like this, and I put roller support, one can be roller support, one can be pin joint. So let's say we normally put the pin joint here, and we put the roller support here. And I apply a uniform tension here, because in this situation, of course, in mechanical materials and all the undergraduate mechanics class, when I apply tension here, I assume that uniform distributed. But if you check the textbook in the mechanical material, the first section tell you that the first term they made some variation. But let's say in our undergrad class, I apply tension and it's sigma over A. If it's roller support here, it allowed it to contraction. So there are strain in the y direction. You can calculate strain based on the Poisson ratio, but the stress should be 0, right? Now I change this roller support to pin joint. So basically now the strain is 0 because now this dimension cannot change. But since it wants to contract, but I fix it cannot contract, it will generate a stress in the y direction. Make sense or not? Yes. That explains why, right? Here is 0, but here is non-zero. But of course, if I change the boundary condition, it could be different thing. Let's say if I change to this boundary condition, then it becomes strain is non-zero. You can calculate strain from the Poisson ratio, and the stress becomes 0 because it's free to contract. Any other question? If no question, we have 4 minutes.
So about this problem, you mentioned like if the point that we're looking at is right in the center. So like what you explained, when those forces counteract each other, is it symmetrical? Or
Sorry, I didn't.
well, like since the point that we're looking at is right in the center of this problem,
Yes.
symmetrical. Why wouldn't why wouldn't it counter each other out? Like why would
Stress is a different creature than you think. It's a stress. Mathematically, stress in the y direction is partial v over partial y. It's not like at a given point, so there's something above me, something below me, and then counteract. No, it's not that. I think you are considering like you have point in the middle and have force applied from above and point applied. That's a force. It counterbalance. Stress is yes. Still correct.
So, like the discussion portion, what are your expectations?
So for the project, actually, some students asked about the format and everything. Let me explain here. The format should be, because I think all of you have done the MOM lab before, something similar. But of course, our TA will grade based on the content, not really the exact format, like it's a font size or double column. I don't really care, like double columns or is anything like font size, or you have some special title or something. I don't really care. And I will tell TA that it really doesn't matter. But what I mean by monthly report is that you do need explanation for the whole report. It's not like somebody screenshot, okay, this is the screenshot, this is the result from the RPT file and list table. We want to know what you are doing there, why, how you get the result, and what this result means. And also the screenshot from the RPT file, there's no unit. And if you just show the screenshot, the RPT file, our TA doesn't know what it means. So the thing that you do need explanation and discussion part. What else? Yeah, that's what I mean. Introduce a what? What do you mean by equation? I come to my office hour. I will have office hour from 2 to 4 this afternoon. So come to my office hour. We can discuss in detail. And if no question with today, thank you for coming and have a great day. Thank you.
I had an emergency on the way here. So I was a little bit late. Is it still okay if I write?
Yeah, of course, it's fine.
I think I got a problem.
Yeah.
Like, is there any chance you would like consider posting like a previous year's like report to get an understanding like the expectation?
Yes. Yeah, I will do it.
Okay, thank you. I appreciate it.
If I don't do it tonight, remind me, send an email and remind me. So sometimes I'll forget.
All right, thanks so much.
Okay.
Like explain like how we got there in the project. You mean like just like saying like what the boundary conditions and voting scenario is, or like actual steps and abacus? Like the whole setup process.
So basically, you just imagine that your TA never know your project statement. So when TA or anyone read your report, they know what you are solving and why you are solving this way and what you are doing each step.
I had a question on the exam. I took at DRT. I couldn't ask for clarification on the second question said deflection.
Yeah.
So I solved for the deflection and the rotation, but then like solve like the V and the theta. And like yeah, I did this all correct. Like I did this correct too.
Okay.
But then also solved for like the same, like the related theta with like derivative of,
So you have this step, you have
Yeah.
this step, you'll get it.
but I have extra step after, but then
It's fine.
because I left because then on here, like exam says like to cross out that I don't want graded.
Okay, it's
So
fine.
I like put cross through on that part, but like and then like so I put
So because
like I did this and I did this, but then I didn't want to have multiple solutions.
okay,
And I wasn't sure if the deflection meant to solve for this or to solve for the theta. So I crossed out.
give me
what
the
I did.
deflection.
Yeah, I was confused.
Deflection.
I was confused which one was meant to be solved for.
So first, deflection there should be no confusion because I never really clarified what is deflection in the past either. So there should be no like confusion part for what is deflection? Is it theta or it is like displacement? And for you, since I will talk to you where you should be fine.
Okay.
So as long as you have this one and you have this one, you should be fine.
Yeah, I did that, and then that just has like some slashes through it
Yeah.
because I wanted to have the other part on there too.
Yeah.
But I did.
Did you keep this one?
I didn't erase it. Yeah, it's on.
Okay, okay,
It just
okay.
has some light.
Then it should be
slashes
fine.
through it.
Then you should be fine. Don't
Thank
worry
you.
about it. Yeah, it should be fine.
Theta 2.
What? What? What?
Yeah, I screwed that up. Through the entire thing. Okay, I knew deflection, I implemented that formula, I think I put a matrix on there, I just didn't solve it.
If I put a smiley face on all of the problems, I probably would have gotten more points.
LTA, it doesn't make a difference.
Can I? To the third one, maybe, let's see. Okay, this, I got it. This, I didn't do I don't think I did the division by 2.
Okay, should be fine because it's
And-
2 points each.
And then going down
That's
a
4
little bit
points.
more. I derived, instead of using that formula, I derived like using the,
Yeah, see, that one is fine.
can I?
Yeah, you can do that. So you use this one, right? It's this one.
I'm studying, yeah, I did that.
That's correct. This is also correct.
Oh, so that works too. Okay.
Yeah.
Cause what I did is I found for those, I think for those particular elements.
Yeah, you can use this one. You'll get the same answer. In space. I think there are people coming. Yeah, we can talk outside.